Hello, am I audible?
Hello. Music बंद कर. Hello. Hello.
Hello, hi, yes, sir.
Yes, sir. Sir, please wait for some time, 5 minutes.
Yes, okay, sure.
More number of participants are joining to now, sir. So please wait for some minutes. Then we start the session.
Okay, sir.
Hello. Hello. All participants are requested to join this meeting. Guests are arriving in 5 minutes. And please, all participants, mute yourself.
AICTE-ATAL-FDP இருக்குது இன்னைக்கு.
Hello? Hello? Voice is clear. Shall we start? Hello. Very good evening to all present here. It's my pleasure to introduce our distinguished speaker for today's session, Mr. Pranav Lad, a dynamic professional in the field of robotics and automation. Mr. Lad is currently the head of the research and development department at iRobotics, Robotics and Automation Private Limited. In this role, he leads new technology initiatives, mentor teams, and drives collaboration between the academia and industry in the field of robotics and automation. Earlier, he worked as a technical sales and application engineer at TAL Manufacturing Solutions Limited or Tata Motors Robotics Division, where he developed new applications using vision systems, IoT platforms, and adaptive grippers, and successfully organized more than 20 national and international exhibitions. He holds Bachelor of Technology in Production and Industrial Engineering from VIT Vellore, Tamil Nadu, and he has an expressive record of 6 international publications, including 4 with IEEE. His achievements include the Special Achievers Award 2017 by the Chancellor of VIT Vellore and a bronze medal at the IEEE RAS International Robot Pride competition held in Malaysia, along with participation in prestigious events organized by NASA, MIT, Harvard, and IIT Delhi. With his rich blend of academic knowledge, industry experience, and innovation in robotics, Mr. Pranav Lad has uniquely positioned to guide us in today's session. So, on behalf of our institute, I request all participants kindly join me in extending a very warm welcome to Mr. Pranav Lad. Hello, sir. Hello. Hello, sir. Hello, Pranav sir. Hello. Guests are starting soon this session. Please stay connected.
Hello.
Yes, sir.
I can't hear any audio.
Hello. Hello, sir. Please start the session.
Hello. Hello, am I audible?
Yes, sir. Yes, sir.
Yes, sir.
You are audible, sir.
Okay.
Please continue the
Yes.
session,
So
sir.
first of all, welcome to our session 3, where we will be talking about robot programming. So a brief introduction about our company. So we are iTech Robotics and Automation. So we are a project integrator, and we deal with robots. Yeah, and we have very big clients like Bajaj Mahindra and clients like that. So we deal with robotics, and we are here to present to you what is robot programming today. Is my screen visible?
No, sir.
No, sir.
Your screen is not visible. Click on the post.
Yes, sir. Screen is visible now.
Okay. So when we talk about robot programming, there are two main aspects that we come across. Okay, first is the robot operating system, where we code the robots and we program the robots there. And we have the robot simulation side, where we simulate the robots and we try to understand how the code is working, so that before we implement on a real robot, we get to know how the robot actually works, whether it collides with objects, whether it collides with the fences, and any errors with the forward kinematics, etc. Okay. Okay. So what is ROS? Okay. So many of us must have heard the term robot operating system, but what exactly is it? Okay. So robot operating system is like a middleware or a framework. So it helps two components to communicate to each other. So at that, when we have two different sensors talking to a controller, the sensors cannot talk uh, to each other. It has to go through the controller, right? So this time, instead of using wires, you do this through ROS, okay, wirelessly. So this is very much used in mobile robotics. This is very much used in mobile robotics. And the misleading fact about a robot operating system is it's not an actual OS. So the operating systems that we normally know are Linux, okay, Windows, but ROS is actually a middleware, okay, and it is not an operating system, though it says it in the name. So ROS has various tools which helps us to program, to simulate, to work with robotics. Okay, so we have one tool called RViz. Okay, so RViz is basically a visualization tool, okay, provided by robot operating system. Okay, and this helps us to understand what the robot is doing. Okay. We cannot control the robot in RViz, but we can understand what is actually happening with the robot. So if we have a mobile robot, we can understand how the LiDAR, which is placed on the mobile robot, okay, how it is scanning the area, how it is mapping the area. Okay, and if when we go to gazebo, okay, gazebo is a proper simulation environment. Okay, and it incorporates a few physics also, so to make it a little realistic. So gazebo has control and visualization. So you can see how the robot is moving, as well as you can actually control the robot. Okay, so robot operating system, I told you all how robot operating system, what it is, but what exactly, how does it work? Okay, so there are a few concepts, okay, that we need to know to understand what is robot operating system. Okay, so first is a node. Okay, so when we need to perform any operation, okay, we need to have a process. So a node is essentially a process, okay, and it is a process which can be assigned to do any work. Okay, so in this node, there's a publisher and there's a message, okay, which is getting published. So a node is essentially just a process. Okay, now a topic is here. Okay, so topic is in between, so it will be in between two nodes. Okay, or even several more other nodes. Okay, and what the main reason a topic is used is it's used as a communication channel. So when we need to communicate with two nodes, okay, we need to send a data to a topic, and then itself the node can subscribe to it. There is no way that two nodes can communicate without a topic. So topic is the middle, okay, in between a node and another node. But what is the data that is getting sent to the topic? Okay, that message, that data, okay, which is being sent to a topic is called a message. Okay, and we have two sides, okay, two nodes. Okay, here what is happening is, here this node is publishing the data, and here this node is subscribing the data. So whatever data is getting stored on the topic, okay, this is subscribing to it, and this is sending data to the topic. So say I have a mobile robot and I have a sensor, which is sending data to a sensor messages topic. So the sensor messages topic can be subscribed by this node, okay, and it can be used by the controller to perform any operation. So if the sensor detects there's an object close by, so the node will be subscribing to the topic. It will notice that there's a small distance, and then it will move the motors accordingly. So this is a brief how the nodes operate. Okay, and this is how a publisher subscriber normally works. Okay, this is a very small system. This is just to explain, but in reality, there will be multiple nodes, and there will be multiple ways that we can perform this operation. Okay, so I spoke a lot about robot operating systems concepts. Okay, so I will just share. You can share it, and you can still speak. Yeah. Okay. Give me a second. I'll just switch to demonstration. So I'll be showing how we use ROS in real life. Okay, is my screen visible?
Sir.
Yes, sir.
Okay, so I'll start from the beginning so we can all understand how this works. So we spoke about a subscriber and a publisher, right? So we can start. Okay. So this is Ubuntu. Okay. For those who are new to Ubuntu, Ubuntu is a Linux version which you can download, and you need to install ROS on this platform. Okay. So ROS can be programmed in two languages. It can be programmed in Python, and it can be programmed in C++. Okay. So now I'll be just demonstrating what a normal. Okay, so this what I'm running now here is the subscriber. Okay, and in another terminal, okay, I will run the talker, okay, which is the publisher. So now what you will see, this is the subscriber and this is the publisher. Now, if you understood the concept a little well, okay, you would require a topic so that this publishes to a topic, and then this subscribes to from the topic, right? So I'll show you that as well. So here you can open another window, okay, and you can just type in ROS to topic list. Okay, so this command, okay, it tells us what existing topics exist. Okay, so we can enter here and we can see chatter, parameter events, and ROS out. Okay, so this this publisher and the subscriber is running on this topic. Okay, so I need to run a command called ROS to topic echo and then this topic. Okay, so this is the topic which I've entered here, and now I will get the data which is being published by this publisher onto the topic, and then the subscriber is subscribing to this data and it is displaying it here. Okay, so this is how a publisher subscriber works. Okay, now this is just, so this is one of the demos. Now if you want to try, you can check what are the existing ROS2 topics now, because what did I do? I terminated both these. So this is so now we can check what topics are existing. So now you can see that chatter has gone. So now there are only two ROS topics. These are always default ROS topics. So these will always be there no matter what you run. Okay. So this is how it works. Okay. Another thing you can check. Okay, I'll run the. So this is the command ROS to run demo node cpp listener. And this is ROS to run demo node cpp talker. So I'll run these two commands, and I want to show you how you can visualize. Okay, so here you can see the talker, okay, is publishing to the topic chatter, okay, and the chatter, okay, is being subscribed to by the listener. Okay, so this is the workflow, and when you want to know what message, so this is the node, okay, this is the publishing node, and this is the listening, the subscribing node, and this is the topic, okay, and the data which is going, okay, this is hello world right now. Okay, I will I'll show you another publisher subscriber, but this is the workflow more or less. Okay, so you can type this using RQT graph and you can get it. What is the workflow right now? What is currently going on? Okay, so I've terminated everything now. Now I have created another Python script. Okay, and I will just run these simply from this. Okay. So don't get confused by all these different terminals. This is just to understand what is going on. Okay, I will run this. So here, what is happening is I'm publishing. Okay, welcome to the ATAL-FDP program. Okay, so I'm publishing to a topic. I can show you the topic as well. So again, rows to topic list. You can check. So now I have sent this to the FDP underscore topic. So I need to access this rows to topic echo FDP underscore topic. Okay, so this is the data being published, and this data will be subscribed by the subscriber. Okay, I hope everyone, all the faculty can follow. Okay, so this is for subscriber and publisher. Okay, I will show you on an actual simulation now how it. Okay, so terminate everything. Okay, so I'll take out most of them. Okay, and now I'll run a turtle sim. Okay, this is a simulation environment. Okay, so this just spawns a turtle bot. Okay, here you can see there's a turtle bot here. Yes, so you can run another program. To run. Okay, oh, just give me a second. Okay, so from here we can move the turtle bot. Okay, on the simulation. Okay, through our keyboard keys. Okay, here, and the beauty of this is from this we can program a lot of stuff. So we can Now we can open up another terminal and we can check out the ROS2 topics. Okay. So now there's ROS turtle1 command velocity, turtle1 pose as well. Okay. So now let's try moving. I'll open this in another terminal. Okay. Okay. So now what we'll do is we'll echo one of these topics. Okay. And you can see that this updates. Okay. So you can see this is updating. Okay, here it updates. And here turtle sim for normal pose command velocity, we are only interested in how much forward it moves and how much it turns. Okay, so that's why you'll only see angular z moving. That is yaw, and this is the x, that is the linear velocity. Okay, so that's what will be moving here. We want to know only how much the turtle moves head. Okay. If we want to know the exact pose of the turtle bot, okay, you may say that this is not enough information. Okay, so we can run another topic. Okay, so we can run this topic, pose. Okay, which will give us more information about the robot's position. Okay, so now when I move the robot, okay, you can see the exact XYZ position, XY position, and you can see the theta position, as well as the linear velocity, angular velocity. So how much is it moving? Is it moving forward? Is it turning? Okay, we can see all these, right? So the reason why I'm showing you this is in mobile robots, we can use these commands. Okay, we can send this data to the controller, and now you can process your data with this without much wires, and you don't need to worry about compatibility with different sensors, different controllers. Okay, you just need to run ROS, and you're pretty much done with compatibility. So now I'll go into a little depth of the codes, okay, that I have created. So you may be asking these publisher codes that I have done. Okay, how did I do it? So we need to create what you call a ROS2 workspace, okay, in which all the ROS2 programs that we create, okay, they are all in this folder. Okay, so all the files that we need to create, okay, we need to create subfolders based on our projects. Okay, so I'll be showing this project also that we had done. Okay, for now I'll show you this FTP demo. So this is the publisher subscriber scripts that we ran earlier. Okay, so here you can see that we are using RCL-Pi. So RCL-Pi stands for Python. Okay, the Python version of ROS. Okay, and we are using, so we have created a class here for ROS, okay, for the publisher. And here we have named the publisher FTP publisher. Okay, and this is the name of the topic that we are publishing to. Okay, so and this is the data that we are publishing to the topic. Okay, so if you remember, welcome to the ATL FTP program. okay, was the data that was shown, okay, publishing so and so data. This was the name of the topic, okay, that we checked, and this was the publisher name, okay. So this is how we create our scripts, okay. This is a subscriber script, okay. So we have created a class, okay. This is an oops, okay. Again, we have done RCL, we have imported RCL file, okay. Here we have used a class, defined the subscriber, okay. Then we have subscribe from this topic, okay, FTP topic, okay, and then it subscribes from the topic, okay. Here to build, so once you say you have created the workspace, sorry, once you have created the workspace, okay, you need to build it, okay. When you build it, you will get all these folders, okay. There is source, the text, okay. Once you build it, okay, you need to source the bash RC. That is a file where you need to tell the system that this Python script is here, okay, and I need to use this directly. So this is about ROS. Okay, any questions so far?
Participants are requested, if you are having any queries, you may ask.
Okay, so I'll show how actual it is implemented in real life. Okay. Before that, I can show a video that we have done. Okay, we have implemented ROS in Vision. Okay. Okay. So this is the Linux environment. Here we are using ROS 1. Okay, this is the main process that you need to run to start ROS in ROS 1. Okay, after this, you need to source the directory, source the virtual environment, sorry. This is on the Jetson Nano. So we had an external SD card that we need to say you have to look into this SD card. Then again, you can see I'm looking at ROS topic list. Okay, now we went to a certain directory on the SD card. Once I move to that directory, now I can run the script. Okay, so this script will open the camera and it will perform a YOLO detection. And through YOLO detection, we can come to know the XY location of the object. Okay, and once we come to know the XY location of the object, we can send that data, okay, to a topic, and we can subscribe it from another place. Okay, it can be anything that subscribes to it. Here we have done it on the same PC, but this can be implemented anywhere else. Okay, so I'm publishing to this object detection topic. Okay, that has appeared now. And now here I'm using echo, okay, to understand what is the data being sent. Okay, so you can see here the data is being published. Okay, this is the data. And now we will try moving the object, and you can see how the values will update. Okay. So I'll just finish a little bit of the presentation that is left, and then we can look at any video. Okay.
Good evening, sir. My question, hello.
Yes, sir.
My question is that supposed to be if we are finding particular object or object detection. So is there any other library other than YOLO?
So you can use any library. You can use SSD, okay, single shot detector. You can use any CNN, okay, any visual CNN you can use, and you can integrate it with ROS. There's no hard and fast rule that you need to integrate it only with YOLO.
Okay. Thank you, sir.
Yes. Yeah. Welcome. Okay. So I was speaking about ROS applications. Okay. So here, mostly ROS is used in the research domain. Okay. It is used mostly to perform concepts, proof of concepts. Okay. And before deploying it on the real world, okay, we perform simulations. Okay. And we will be showing you this later through RoboDK. And so here, the main reason that we use ROS, okay, is especially because of mobile robotics, because mobile robotics has a special ROS package, which makes it very easy for navigation called ROS to nav. Okay, so ROS to nav makes it very simple to integrate, sensors like LiDAR, okay, your accelerometer, your gyroscope, even to integrate odometry, okay, the data from your encoders, rotary encoders, okay, and ROS can be used. ROS can be used for mapping. Okay, so these mobile robotics often use SLAM, okay, which perform simultaneous navigation and mapping. Okay, simultaneous localization and mapping. Sorry. Okay, so localization is basically coming to know where the robot is in an environment. Okay, so if the robot is placed in a room, okay, it can come to know where it is in the room. Okay, and mapping is basically, we all know that it understands the surrounding. So SLAM, okay, mobile robots use SLAM very often. So it comes to know where it is in the room, and as well as the entire surrounding. Okay, so it can be used in map. Okay, it detects some object close, it will send the data key. I'm 4 centimeters away, 5 centimeters away from an object. Then the data will be subscribed from the topic that the sensor has published. Okay, and then the robot can navigate around. Okay, so it can also be used in control. Okay, and it can also be used in vision. So I showed you an example of vision. Okay, and I can also show an example of how it is used in real life in navigation through one of the YouTube videos. Okay. So I can show you here. Sorry. Okay, so this, if you may recall, okay, this is RViz, okay, where the robot is visualizing itself. Okay, this is a platform that you cannot control the robot. Okay, here is the camera feed, and here are all the real life data. So you can see that the robot is moving in RViz. You can see it is moving from the camera and the real feed. So there are different types of SLAM. Okay, here in this SLAM, the map is already provided. So the robot already knows how to navigate, but in case any obstacle comes in front of it, it can still avoid it. And if there's any new object that has been placed in the environment, okay, the lidar can map it and send it to RViz. So next time another AMR goes, autonomous mobile robot, or another, if we require latest data of the map, okay, we can send it, okay, or we can use it. Okay, so you can see how the robot navigates. Okay, and as the robot navigates, see there's a pointer to understand where it needs to go. So sometimes these robots are given a goal, and in an environment they have to map it or they have to navigate through it. Okay, so this is about it. And now we'll explain to you how RoboDK is used for simulation. Okay, so now that you have understood how robots are programmed, or a basic understanding how ROS can be used to program a robot, now we'll look at simulation. Okay, so how a robot can be simulated. So before we deploy it on an actual robot, okay, we can understand how the robot is performing, okay, with our code. So, okay, everyone. Now you just to know about the ROS programming and all. So now we should start about our journey for a new simulation software, which is the RoboDK. First of all, can you all listen to me? Can you hear me right now?
Yes, sir.
Okay, thank you very much. Uh, Before going further, I will first talk about something RoboDK, what is it is and how can we use it. Okay, so first of all, RoboDK is a very powerful robot simulation and offline programming software. Okay, can everyone see my screen?
Yes, sir.
Okay, uh, okay. So let's start again. Uh, like I said, robotic is a very powerful robot simulation and offline programming software, uh, and it is easily available to anyone who want to start its journey for simulation in robotics and other areas. Okay, like I said, it is a simulation software. So first, we will have to understand why we need simulation and the use of robotic simulation software. If you are a beginner in a robotics programming, it is
very risky to directly start on robot programming or operating of robot. So, using this simulation software, we can test how our program and how good we can operate a robot uh, while while avoiding any crashes or damages to our robot. Okay, as a person, I also don't want to damage any of my components. So rather than jumping into direct programming, I would first like to test my programs and look how good I can program and operate the robot. So this is why we start with the robotic and the simulation setups. Okay, in this environment, okay, in robotic simulation software uh, environment, we can have any robot and test whether how we can control it. Okay, so in this, we don't have any risk of damaging any real component. If you know, the robot components are not that much of cheap. They every component of a robot is highly costly, and if we directly jump into operating it without any practice, it can be guaranteed that we will damage a robot or a robot system which we will going to operate. Okay, so to avoid that, we must have some knowledge about how to program or how to operate a robot. And rather than going on an actual robot, we can try here with the different robots which are available on robotic software. Okay, first of all, as you see on screen, you can see the library of robotic software. There are multiple robots available, and you can choose according to your need. If you are going to use a real robot, you can even find your real robot here, or you can simply create your own robot in this software by importing its step files. But if you are starting with the robotic simulation software, I would suggest to use these available robots for you for easy operating. Okay. If you have time, you can explore um, these categories, because if you explore, you can find out so much about robotics and the tools we use with the applications. Okay, as you see, there are different brands here available, different types, whether it's of the degree of freedom or depending what type of robot they are. Okay, you can also choose with the reach of a robot you need. Okay, and the weight and all the repeatability functions. Okay, so if you have robotic software, or you can just go on Chrome software and go for robotic library. You can also find it there and explore the robots and the different tools you can use in robotics software. Okay, now you can see this is the how robotics software window looks compared to other software. It is much more comfortable, because if you open a new software and you get so many functions, you have one kind of what we say, we would like to know everything in a very fast way, as a curious person. So having less commands on your screen can give you a time to adjust yourself to a new software, and that is where I like robotics software, because uh, it it has very less commands and functions, so you can explore slowly and uh, make a perfect good simulation. Okay, so before uh, I think someone is uh, trying to mess with our meeting, so I would kindly request you to stop doing this, whatever you are doing on my screen. Okay, If there are faculty available, I kindly request you to talk with your students, or because I am seeing this red line on my screen.
Yes, sir. We'll take care of that.
Okay. Okay. I think I have talked so much about robotic software. Now it's time to start our simulation. Okay. Uh, as you see, robotic, first time you open, you can going to see this window. In this, there are different functions available. There is import import panel. For this is the load file where you can load your robot offline, which is available in your PC. Next, for their library access, with this you can directly go to their library and import different robots. Next, you can see the reference command and the target command. Okay, you can have different views like top view, okay, right and front views. Okay, next is this is a it is a uh, collision panel, where which is the main reason why we use robotics or software to check whether the robot will collide with any component on our robotic system and how we can avoid it. Okay, we will focus. We will talk about this in later. Okay, next, this is the Python script command, where we can add different Python script in our simulation, which mimic the real actions of a robot, whether it's welding or a spray painting type of action. Next is a robot. It is the robot programming command, where we can create a program consist of different motions and the Python scripts. Okay, here the simple motion commands are available. Next is call program. Okay, this function we going to use inside our program when we going to run a simulation.
इतना कोई इनामात में लगेगा अल्लाह के नजदीक कामयाब।
Okay, I have explained you how the what are these functions which we can see on our screen. Okay, now let's import a robot which we are going to use for our first simulation. First, I will go on to robotic library. Then I want to select a robot which is easy to operate and don't look that much. Rather than focusing on its looks, I will use a simple one, and which is the easily available. I will go with the universal robots. Okay, as you see, there are specifications you can see on here. I will choose this one, download. Okay, I have downloaded this robot. Now we are going to use it in our robotic software. First, just open your file, go to download. As you can see, this is the robot we downloaded. Just open it and see. You can have your robot in your simulation environment. You can try to play with this with your mouse. Okay. This is
Hello, sir.
yes.
Can you please repeat that how we taken the robot?
Okay, fine. Yeah. Just click here. You will go directly to the web page of Robotica library. Okay. Now you can select directly from any robot available from here. Okay. But just to show you how can you choose your the robot you want, I will go to brand. Okay. Choose any one of them. Previously I choose universe robot. Let's see any other robot. Let's go for the ABB one. As you can see, these are the ABB robots. Okay. Now let's try to choose one. Okay.
Actually, it is not showing in screen, sir.
Okay. Let me see. Okay, sorry. Can you see it now?
Just right.
Yes, sir.
Okay.
Yes.
Yes. Okay. Once you go to the robotical library, you can find different robots. Okay. All you have to do is just download any one of them. Right? You can see different robots and choose whichever you want. I will just go with this one. Okay. It's downloaded. Now we will go to our Robotica software. Yes. Okay. Now just go to the file. Okay. Just open. In your download folder, you can see the robot you downloaded. Okay. Just open this and you have your robot right in your front. Okay. Now let's take a look at here what we see. This is a simple session folder in which if you just want to have new, you can just add one here. Okay. As you see, it is an empty session now. Let's go with our exported robot. Okay. Next is the frame of that robot. Okay. Let's before discussing about much more frame, I would like to show how can you control this robot. Because as a person, I also wanted to know when I started that how can we control this robot. Okay. So as you can see, there is a Cartesian jog movement and the joint axis movement. Okay, these are the two most basic methods we use for the robot operating or controlling of robot. In first, you can control a robot with the XY coordinations, and the second by giving the motion to a specific joint only. Okay, let's just show you. Right now, I want to move it using Cartesian jog movement. So if I just take my mouse and click here and scroll up and down, you can see the robot is moving in XY. If you see carefully, there are different axes are moving at once. Okay. All right. Let's go for Z. Okay. So in these different joints are moving at once, and they are trying to focus on their tools and XY coordination. They are trying to focus to move according to the tool's endpoint location. And now let's go for the joint axis movement or okay. If you see, there are different joints. Okay, with uh, okay. Now what the Robotica has done, it has already created a library with the real limitations of robot movement. Okay, you can see there are plus minus range of angles in this, which is the real limitation of robots movement. Okay, if you just try to move this, you can see how the robot will move in different joints. Okay, when I use joint axis movement, the only one joint is moving and all other joints are in rest. You can either use this control to control a robot when you don't want to change its uh, order link's position, or you can directly use uh, Cartesian jaw movement if you have a specific coordinate where you want to teach robot. Okay, so this is the how you are going to control your robot. Okay, the another way of controlling this robot is just to go there a reference frame. As you can see, this red, green, and blue are its reference frame. If you press Alt key in your keyboard and try to drag it, you can also directly move and drag the robot. Okay, now we have got our robot, but just playing with a empty robot is not that much interesting. So we are going to create a robot. We are going to create a robotic cell where we are going to do a simple program of spray painting. Okay, rather than creating a large system, I will just create a small system which will demonstrate you uh, how can we create a simulation. Okay, now here I am again on RoboDK website. I will go into library first. I want to have some tools for my robot, because in real life we are not going to just only use a robot. We are going to use different tools for the specific application. Right now, like I said, we are going to say a basic spray painting operation. Okay. Okay, as you can see, there are tools. There are different tools. This is a laser cutting tool, grinding tools. Okay, but there are different tools available. But what right we want? We want a spraying tool, which is a spray gun. Okay, so we will try to look for it here. Okay, as you can see, this is a paint spray gun, and this is what we need for our first program. Okay, now I have a tool. As we are okay, then let's. Okay. Now I have downloaded my tool, but I want to import it, and I want to import it right here. So rather than you don't have to do anything in that much, just like we imported the robot, we have to import it our tool, and as you see, it is directly attached to the robot arm. Okay, it is directly attached to the robot arm. Why? Because the tool is programmed where it should be a joint. If you just double click on tool, here you can see the flange. It is means the tool will going to attach to the robot flange. Okay, now I want I have a robot, I have a tool, but what I am going to paint. Okay, so again I will go to the website. Okay, now I want to have one object which I can paint. Okay, let's go to the objects. Here you can see different objects. You can choose any of object from here, but for you to show the different movements of robot, I have created my own object here previously. So this time, rather than getting a object or design from Robodecay, I would also show you how you can use your own design in the simulation software. Okay. So for it, you don't have to do anything. Just you have to make sure that you have a step file ready in your PC to import here. Now I will go to library. Okay. There are different robots I have previously downloaded. Now I'm going to use this object. Okay, this is a step file of a design. I will going to open it. Okay, as you see, this is a curved object. Okay, now when I import it, it is directly located at the base of robot, but I have to move it away from robot before starting any program or simulation. So here where we are going to discuss an important term in this robotic software, which is frames. Okay, so what is a frame? First of all, robot don't have eye, so robot need a reference system to understand its position. In so this is where frames are act as a coordinate system to uh, find out the position of the robot and the end position of its tool. Okay, another term in this is the TCP. Okay, as you can see this reference frame, it is a reference frame of TCP. It is far more away from the endpoint of spray gun. Why? Because this is the point where we need our center point of tool or the spray. Okay, so we have everything. First, I would adjust these all according to my needs. First, with the robot. Okay, just I will move different joints. Okay, let's see from a different view how it looks. Okay, okay. I have just adjust my robot according to my need. Okay, now let's adjust this object. Just double click on object. You can see the coordinates of object. Okay, now let's come back to our topic, which is the frames. As you can see, these red, blue, and green are nothing but our origins, the origin of that tool, robot, or TCP. Let's look here. We can see uh, which object is which object's reference frame we have just opened. Here is the inspection object. Okay, if you see uh, reference frame, or you just see or unsee it from here. Next is to select to which to with respect to it's going to move. Uh, like if we have a chair, okay, and we are going to sit on a fixed position, we have to first move according to something or in a sitting situation, we have to move according to the location of chair. Okay. So just like that, if we are going to move our robot, okay, we have to have a fixed point to reference to which we are going to place our objects. So here I would have same origin as the robot, which is the station, our station file. Next, I would adjust tool object here also. Hmm, okay, now I have placed my object, but I kind of feel that object is whether it's in the reach or not. So I will just type first check my reach. Here you have the function available to check its reach. Okay, if you don't see for first time, you can just right click and add it from your workspace. Okay, add workspace, check, where you can see it is within its reach. There you can see the different circles here. So these are the circles for different endpoints. So we have our small system ready, which is need for a basic simulation. Now, uh, until now, I moved a robot manually, but I want to create a program in which robot will move to the points I have given it. Okay. So first, and that's this. You can see here a target option. If you click right here, you can save this position as one of its target. Okay. If I move again this robot, just click it, I will move away. Okay, load it. Just click on it. Okay, it will came to that position according to the same joints which it was in previous. Okay, now how we are going to use this target to move this robot according to this surface. Okay, now the robot has given us one function called pitch on surface. Okay, with this command, you can directly go to any object and select its position as a target or the point where you need to take your robot. Okay, if you see from the front view, you can get to know. Okay, you can see how the robot is adjusting itself according to the surface. Okay, it's always trying to stay normal to the surface. Okay. So you can use this command when you have object placed in different orientation and want to move it according to your curved surface or any kind of shape. So first, uh, before creating program, I want to have one home position for my robot. So okay, I will also add a new position. Okay, I want to save this position as my home position, which is far away from my object. Okay, target. I will save it as just rename home position. Yes. Okay. Now I previously select one target here, so I will also rename it as a save point. When we are going to perform a program, we never directly go to the exact position. We use different position. So basic position is home position. From there to a straight position, and then we are going to the pitch position where the spray painting or different operation which can be anything like drilling, welding, or even grinding. Okay. Now I will go to program, select teach on surface. Okay. As you can see, robot is directly came to the teach point. I will select this one at first, then second, third, fourth, fifth, and the last. Okay. Now we got different. Okay, last one is not there. Yes. Then now we have different targets or different coordinates to move robot. Let's try to check there. Okay, now you can see how the robot will move when we create a program. Right now I am dragging the robot manually by clicking on the positions. But now the next step, I want to create a full motion of this operation of spray painting. So here where we can use command function. Okay. So rather than I would also change the name of these. Okay. To know what are these targets for, I will go to rename group and select them as a paint. Okay. As you can see, these are the points where the spray painting is going to start. Again, after, okay, let me just adjust it. Okay, copy this. Okay, from here, let's go to the save point, add another target here, then home, another target. Okay. Okay, now we have all the points we need for our program. Now we are going to create one program, one basic program. Let's go select all these. Okay. Now just right click and you can see create program option. Or you can even go from here. Okay. Now you see how the robot will move when if we program it according to this point. Okay, as you can see, there is a problem. You have to just change its motion to solve this problem from linear motion. Just let give it some more freedom. Okay, again, I will run this. Okay, as you can see how it's going, to run. Let me show you again. Okay, as you can see, it's moving like this. Okay, we don't want it. Okay, now it's going to move straight. We can change another motion from here and test how it can, what kind of curve movement it can have. Okay. Just again make it linear. We want simple. Okay. Okay. So this is how you create a basic simulation program. Right now, after this, if you just you can even export your simulation, okay, or create a robot program from this. Okay. Okay. So this is what you need to do if you are going to start with the robotic software. When you are going to learn a new software, it is just like you are going to play with a new game. The more you play with it, the more you are going to understand it. Okay. So first thing you need to do for robotic is to install it in your PC available. Okay. You can directly just go to their websites. Okay. Download robotic software. Okay, here you can get the direct option, which is the free software with 1 month 1 month plan. You can use and try robotic software for 1 month. Try to do different simulations. Okay, even same these type of, you can easily access YouTube playlist for robotic software, where you are going to learn more about how to use different functions of robotic software. Today I have just show you one basic simulation program, okay, which takes less than 15 minutes to do. Okay, I will try to recreate this same program within uh, with very fast. So actually, you can see, rather than it is some hard simulation software, it is just like you are going to play with a game. Okay, now let's start with the new session. I hope everyone can see it. Okay, new session. Now I'm going to add a robot.
Sorry to
We will
interrupt you, sir. We
Yes,
have next section in line.
yes, yes.
Yeah.
Yes, I'm just going to show them in a very short. Okay.
Yes, sir.
Okay. Now robot is done. Tool is done. Done. Object is done. Let's move it. Okay. Save this as a target. Go to program. Switch on surface. Okay. Done. Select all these targets. Go to create program, and then you just created your program. Okay. It was very less. You can say even less than 5 minutes. Okay. You can see the movement of the robot and the program we just created. Okay. Well, with this, I would like to conclude our today's meeting. I hope you understand and going to try the robotic software. It is a very easy one, and anyone can start with the robotic software. There are multiple videos available on YouTube. Okay. Since you have another another lecture, okay, I will not take your much more time.
Okay. Thank you, sir.
Thank you.
So before we move forward, I would like to invite the participants to share any questions, clarifications, or reflections that you need. You may ask. Please feel free to interact. You can put your questions over here. You can unmute yourself and you can ask the questions.
Good evening, sir. Am I audible?
Yes, sir.
Yes, sir. Sir, very informative and nice session, sir. Thank you. Sir, if you don't mind, kindly share your contact for further queries regarding this.
Okay.
Yes, sir. We will share it later on. We can share all the information of all these speakers. So please stay on the line.
Okay. Thank you, sir. Thank you, sir. Nice session, sir.
Thank
Yeah.
you very
Any
much.
other? So any other participant? Okay. So, sir, it seems that the participants do not have any queries or questions at this moment. So we take it as a positive sign that your explanation were very clear and well received. So with your permission, we now proceed further.
Yes, sir. Thank you, sir.
Okay, thanks. So it's an heartfelt gratitude to our distinguished speaker, Mr. Pranav Lad, who is the head of R&D department at iRobotics, iTech Robotics and Automation Private Limited. So for delivering a such knowledgeable and inspiring session, I thank him. Sir, your session was truly an enlightening experience. The way you shared your knowledge, the robotics and automation, and connected it with the real world industry practices kept us all deeply engaged. So, more than just not a theory, your live demonstration on ROS application and robotic simulation software gave us a hand on flavor how the robotics can be applied in real problem solving. So it was not just an informative, but also an inspiring to see the future of technology which unfolds before our eyes. So your words today were not just about the machine and codes, but about nurturing the curiosity, thinking beyond the boundaries, and believing in what we do. So I'm sure the knowledge and motivation you shared with us will stay with us for a long time, encouraging both the faculty and students to take the bold steps of the research, innovation, and the technology. So, on behalf of everyone present over here and S&D College of Engineering, I once again extend a big thank for your spending your valuable time with us, for patiently answering the queries, and for making the session truly memorable. We look forward for staying connected with you and learning more from your journey. So, thank you so much, sir.
Yes. Thank you for my side also.
Okay, sir. Thank you so much. So, dear participants, we truly appreciate your active involvement throughout the session. The energy, enthusiasm you bring add so much value to this program. We now request you to kindly stay connected with us for the next session that we will begin shortly, just after 5 minutes. So, let's all come back with the same spirit, ready to learn, share, and interact. So, we look forward for your continued presence to keep the momentum going. Thank you.
मुझे रिटायरमेंट के बाद हर महीने लगभग 2.5 लाख की इनकम मिलेगी।
Hello, Kalpesh sir, are you there? You are muted. Please
Yes,
unmute.
sir.
Yeah.
Good evening.
Good evening, sir. Good evening. So we are moving forward for the second session. So
Okay.
I will request Gujarati sir to start the session.
A very good evening to all present here. I, Professor Tushar Gujrati, Assistant Professor, Mechanical Engineering Department. It is my pleasure to introduce our respected speaker for today's second session, Mr. Kalpesh Patil, a highly experienced professional in the field of EPC, that is engineering, procurement, and construction projects. Mr. Patil is a mechanical engineer with more than 20 years of experience, currently working as senior manager at Gammon Engineers and Contractors Private Limited, Mumbai. He has complete responsibility for large EPC projects from conceptualization to execution, including technical specifications, material procurement, inspections, erection, commissioning, and testing. His expertise covers material management, project management, and coordination across residential and industrial projects, with a flair for adopting modern construction methodologies while maintaining quality and safety standards. Mr. Patil has successfully executed major projects such as Bhusawal TPP, Jajjar TPP, KDMC Sewage Water Treatment Plant, Guwahati Water Supply, and Chennai Metro Rail, handling prestigious clients like NTPC, BHEL, Tata Projects Limited, and L&T. He has also completed advanced certifications including ASNT Level 2 in non-destructive testing, power plant operations and maintenance, industrial health and safety, and the postgraduate executive management program from SP Jain Institute of Management and Research. With his extensive knowledge and practical experience in large-scale mechanical and EPC projects, Mr. Kalpesh Patil is well placed to share valuable insights with us today. So, on behalf of our institute, I request all participants kindly join me in extending a very warm welcome to Mr. Kalpesh Patil, sir. Welcome, sir. And I request you kindly start the session.
Okay. Thank you very much, sir. Thank you for the brief introduction. And first of all, I will thanks to SNDT College of Engineering and Research Center, EVLA, and for this opportunity given to me. I am especially thankful to the principal DM Yadav sir and coordinator of this program ATAL-FDP, Dr. H.U. Pawar sir. My topic regarding this is the robotic systems. I will just share that my screen with you.
Yes, sir. It's visible.
Yes, no? Just 1 minute. Yeah, it's visible now. Hello.
Yes, sir. Yes, sir.
Yeah. I'm just starting. Regarding this topic's robotic system, this is one common view that it's robots versus as a humanoids. We will always think robotics should be behave like our human, and it has the all the characteristics regarding like shapes with their torso, head, arms, legs, and they should always use these actuators, AI informations, then sensors, so that our work will make easier and effortless. We'll be studying these industrial manipulator types of robots, which are mainly used in construction, manufacturing fields. Basically, in construction, we have to use the various types of plants and machinery which is having the robotics, which save our time, which save our cost, and up to the satisfaction of the customer, we are able to handle the projects easily with the robotics and automations. Briefly, I will just give the pattern or sequence of this presentation. It's like the introduction of the robotics, classification of robots, robot accessories, coordinates, then how are the work volumes and reference frames are created to apply with our requirements, then what are the robot programming and robot applications in construction industries. This is just a history of robotics timeline. In 1922, J.K. authors that Capek wrote a story about these robots and introduced the word robota. After that, it is termed as a robotics in various levels: 1955, 1962, and then 1973. We are always aware about this sensitivity micron introduced this T3 model robot, which became very popular in the industry, and now it is acquired by the ABB, which are very well-known industry in the robotics fields. Basically, the robot classification according to their use and various definitions given in the Robotics Institute of America. It is variable sequence robots, then playback robots, numerical control robots, and intelligent robots. Variable sequence is another device that performs the successive stages of a task according to a predetermined methods. Playback robot is human operator performs the task manually by leading the robot. Numerical control is, as per the name, the operator supplies the movement program rather than teaching it the task manually. And intelligent robots at use nowadays we are seeing these are the very much familiar and popular among the industries. A robot with means to understand its environment and the ability to successfully complete a task despite any changes. Uh, It is defined as a reprogrammable multifunction manipulator designed to move material, parts, tools, or specialized devices through variable program motion for a variety of tasks. It possesses certain anthropomorphic characteristics such as mechanical arm, sensors, and intelligence to make decisions. The third is one is very much expectation from these robots like intelligence, so that we can complete our work with minimum efforts. Basically, in the robot accessories, these are the parts which are mainly available in any type of robot systems. It consists mainly of manipulator, and that may be called as a rover. This is the main body of the robot, and it consists of links, joints, structural elements of the robot. Second part is the end effectors. This is the part that generally handles objects, which is directly touches with the objects, makes the connection to the other machines and perform the required tasks. It can vary in sizes, complexity from end effectors on the space shuttles to a small gripper. It depends on the actual what are the use of these robots and applications. Actuators are the muscles of the manipulators. Common types of actuators are servo motors, stepper motors, pneumatic cylinders, by which the program is easily handled. Sensors are used to collect information about the internal state of the robot or to communicate with the outside environment. Robots are often equipped with external sensory devices such as vision system, touch, tactile sensors, which help to communicate with the environment. The controller receives data from the computer, controls the motion of the actuator, and coordinates these motions with the sensory feedback informations. We'll see some robot configurations which are very much popular in the industries. Apart from that, this configuration, there there is the basic configuration available in the industry, so that we can decide what type of robot system is required for our applications. In industry, there are so many applications or so many areas where we need such automation or robotic system to develop at our site. In mostly, these are the configuration which are explained here, which has the rectangular gantry, which is very familiar with Cartesian system, which has the three linear joints that orient the end effector, which are usually followed by additional revolve joints. Here we can see that gantry configurations. This is very popular in the industries, so that vertical, horizontal, and z-axis movement is possible by this. Cartesian robot work envelope. This work envelope is defined in this diagram. Here we can achieve the area like horizontal, vertical, and traverse stroke also. We have to define these areas first, and then we have to choose our robotic system, which is the requirement is there, what is the load capacity is there, and what are the work to be performed at. These are mostly used in the workshops. This is the second popular configuration, which is called cylindrical, which is having the two prismatic joints and one revolute joint. This we can see by this picture. One is revolute and one is two are travels are given. This cylindrical robot work envelope. Here the work envelope is developed by this circular motion, horizontal reach, and this vertical reach also. Means three movements, three areas are covered by these cylindrical robots. Another is spherical joints. The basic diagram is shown here, that rotation is also there, swelling is the spherical movement is also there. These are basically called ball and socket joints. This mechanism allows 3 degrees of freedom and rotational movements around a central point, similar to just a human shoulder. The envelope is like this. We are covering this horizontal stroke, vertical stroke. In the plan and elevation, we can easily see how much area these robots can capture for our work. This articulated configuration. These joints are revolute, similar to a human arm. This one rotation, two rotation, and third rotation, and this one traverse rotation. This is SCARA system, very much popular. Selective compliance assembly robot arm. They have two revolute joints that are parallel and allow the robot to move in a horizontal plane, plus an additional prismatic joint that moves vertically. These configurations are shown in one picture, so that we can easily use this configuration at our applications. And this basically required while deciding which robot configurations do you need for your applications. Another is the reference frames, which are the reference frames is are given in word reference, joint reference, and tool reference. Frame which is universal coordinate frame as defined by the XYZ axis. In this case, the joints of the robot move simultaneously so as to create motions along the three major axes. Joint reference frame, which is used to specify movements of each individual joint of the robot. In this case, each joint may be assessed individually and thus only one joint moves at a time. Tool reference frame, which specifies the movement of the robot's hand relative to the frame attached to the hand. The X, Y, and axis attached to the handle define the motions of the hand relative to this local frame. All joints of the robot have simultaneously to create coordinated motions about the tool frame. These are the robot reference frame, which are primarily required for ordering of any type of robots, so that manufacturers can analysis our requirement and give the suitable robot configuration and their reference frames, so that proper selections will be done while procuring the robots. Uh, this work envelope concept is very much important, since what are the requirements are there from your end that should be satisfied by these robots. So the proper selection of robots can be possible when you understand the basic requirement of your job and the space availability. What the tasks to be performed by these robots are very much important to decide the inquiry. Depending on the configuration and size of the links, wrist joints, robots can reach a collection of a point is called workspace. Alternatively, workspace may be found empirically by moving each joint through its range of motions, combining all space it can reach and subtracting what space it cannot reach. We can easily understand what the workspace is available for this movement of these robots and which is not available. We have to define first before procurement. These are the work enveloped by pure spherical jointed arm. Here we can see the horizontal reach, vertical stroke also, and swing also in our plan and elevations. Parallelogram jointed. This robot system gives the directions also. What are the workspace is available by this. Readiness assessment test. This is simple a test. What are the your requirement, how you are assessing your requirement, and how you are communicating with the manufacturers. We have to prepare a detailed response for the following readiness assessment. For example, what type of robot configuration does the ABB 140 robot have? This robot configuration, first of all, we have to decide whether the manufacturing place is available, and can you find out your
Sir, your voice is not audible.
for the manufacturer, we can ask specific configuration or specify what are the use of our typically has 3 degrees of motion. Rule involves rotating the disc. Hello.
Yeah, now it's
Hello.
audible, sir. Yeah.
Yeah. Okay. Uh, we are discussing about these 3 degrees of freedom, which are rules involves rotating the wrist about the arm axis, pitch, which is up and down rotation of the wrist, and third one is yaw, left right rotation of the wrist. This movement is very popular in the robots. End effectors is mounted on this wrist. Wrist motion is very much simpler method is shown in the pictures, like attachments of robot arm, pitch, yaw, and rotations. These are the control methods, non-servo controls, implemented by setting limits or mechanical stop for each joint and sequencing the actuation of each joint to accomplish the cycle. Endpoint robot, limited sequence robot, bang bang robots. No control over the motion at the intermediate points, only endpoints are known. These are non-servo motors. Programming accomplished by setting desired sequence of moves, adjusting stops of each axis and their sequence in the programs. And these are the low cost and easy to maintain, reliable, relatively high speed, repeatability, then limited flexibility. Typically, these are hydraulic pneumatic drives. Servo controls basically in up to point to point, then continuous path control. These are the closed loop control used to monitor position, velocity of each joints. we will discuss about this point-to-point control and the line continuous path control. Here, only one endpoints are programmed. The path used to connect the endpoints are computed by the controller. User can control velocity and may permit linear or piecewise linear motions. Feedback control is used during this motion to ascertain that individual joints have achieved desired location. Often use hydraulic drives, recent trend towards servo motors, as we have discussed. Loads up to 500 pounds and large each. Applications are pick, place types operator, platizing, machine loading. What are we are seeing these robotics information that are useful in your day-to-day lives while selecting the robots. These are the continuous path control. In addition to the control over the endpoints, the path taken by the end effector can be controlled. Path is controlled by manipulating the joints throughout the entire motion via closed loop control. These are the applications: spray painting, polishing, grinding, and arc welding. We'll see what are the robotic programs are developing, and so in so many countries, and latest development is mostly on these programs. They typically perform using one of the following, which is online or offline: teach pendant and lead through programming. Offline defines robot programming languages, task level programming, which are already feed up in the robotics. We'll see which is very popular use of teach pendant. Handheld, it is a handheld device with switches used to control the robot motions. Endpoints are recorded in controller memory, sequentially played back to execute robot action. It's very handy to use. Trajectory determined by robot controller, suited for point-to-point control applications. It is easy to use, no special programming skill required. Useful when programming robots for wide range of repetitive tasks for long production runs. There is a lead through programming where lead the robot physically through the required sequence of motions. Trajectory and endpoints are recorded using a sampling routine which records points 60 to 80 times a second. When played back results in a smooth continuous motion. Large memory requirements. These are the programming languages, which is the need to interface between robot control system to the external sensors to provide real-time data which changes based on the sensory equipments, which is computery based on geometry of the environment, ability to interface with CAD/CAM system, which has meaningful task description, offline programming capabilities. In the industries, there are a large number of robot languages available, like very much popular C, C++, AML, VL, AL, REL, Robot Studio. Each robot manufacturer has their own robot programming languages. No standards exist. Mainly, it depends on what are the your applications are there. Portability of programs virtually non-existence. Here again, one practical point of view, we can just discuss what are the activity and what are the use of your industry, what is the requirement. Such example is given here. You have to discuss an activity that you think can be automated by using a robot. Simple, in your workshop, some activities there. We have to define that activity, and then uh, what type of work or what is your requirement we have to define. Then what are the special tools are required for this activity to perform, we have to decide. And then we have to uh, study and justify whether this activity is economical or not. And then we have to go for the development. These are the stages to adopt in the industries. Here in the construction industries, many key technologies are available in the market, and their applications are available in the industries. First is robots are used for tasks like bricklaying, concrete pouring, welding, enhancing precision and speed while reducing labor cost. We'll see these one by one. Uh, Another one is drones. Drones provides real-time aerial data for site surveying, progress tracking, identify safety hazards, enabling better decision making and faster inspections. Nowadays, we are seeing drones are mostly used for these structures at high level, which the human cannot access the points for inspection. That time we are using the drones. Artificial intelligence, AI powered machineries are available nowadays in the industries. That software analyzes vast data sets and to optimize the project schedules, allocate resources, predict risks, and improve overall project efficiency. 3D printing. This technology allows for the on-site creation of the custom building components with high precision, reducing material waste, shortening timelines. Prefabrication and modular construction. These prefabrications are also done earlier also, but these are the manual process available in the construction industry. Their use is only to avoid the space and avoid the time uh, for the construction. But in nowadays, this prefabrication is done by robotics at the workshop, so that your lead time will reduce and you can easily erect these sections at different sites. Automation enables the mass production of standardized prefabricated component, significantly reducing construction time and waste. Exoskeletons. Wearable exoskeletons are adopted to enhance worker strength and endurance, improving worker productivity and safety. Internet of Things. IoT sensors and devices connect to buildings to enable real-time monitoring and automation of functions like energy management, making buildings are more sustainable. We will use the robotics in different construction activities. First is the very much popular, which is the demolition. In demolition, remote control demolition robots are used, which are mainly concrete sawing, demolitions, and water-based concrete demolition and recycling. These are the makes available in the market mostly are Husqvarna and Broke. These are the mostly foreign makes available. In India, we are means this Indian make we are not available, and mostly client prefer according to their budget these Husqvarna and Brook. But these are the very much costlier. The contractor selects as per their budget. Surveying. For surveying, drones are especially used for area mapping, surveying construction sites, allow for real-time servicing, improve logistics, and collaboration across construction teams. For drones, major manufacturers are Idea Force, Historia Aerospace, Garuda, Paras, and IG. We all aware about these drones. These are very much familiar in our day-to-day life also. While in cricket also, game tournaments, various where the space is uh, abundantly available, but we cannot go and access the data from there. These drones are especially used in our constructions. There are so many site levels are there. In that, we are using drones so that each data and the progress of the construction can be accessed and knowledge. Paving work. These paving robots are mainly for the paved roads with bricks or concrete. Relieve workers from physically straining works, improve efficiency. International players like Fanuc, Kuka Robotics India are main manufacturers for these paving machines, which are controlled by these robots. Concrete finishing. Concrete finishing, automatic concrete troweling and paving. automates tasks that is repetitive and hard for humans to do well. The makes definitely this space robotics, Okibo offers such type of robots, however not expanded in India. Uh, in construction industry, these are the constraint we are facing mostly, that we will not find any Indian make robots for these construction activities, because that maybe the we are lagging in this technology for this construction. And second thing, all we aware that fund is also an issue for the contractor to use such type of use costlier equipments or robotics for the applications. Welding of 3D structures, steam beam assembly, and steel cuttings. This is very much a popular system in welding. Earlier, what I saw, that first robotics is for the welding, and it performs the activity with more accuracy. Robotic pipe welding uses automated systems like spool welding robots and AI powered systems to perform precise, consistent welds on cylindrical pipes, boosting productivity, quality, while reducing the need of skilled welders to perform hazardous and repetitive tasks. In most of the oil and gas industries, we have to face this situation, like hazardous chemical we have to handle. At that time, no skilled welder can go inside the plant and weld for that particular confined space. At that time, this robotic system is so much useful for the contractor. These manufacturers are mainly ABB, Fanuc, Yaskawa, Epson robots are the manufacturers for the weldings. And apart from that, now in welding, lot of makes are available in India for this operation, depending upon the use. Bricklaying works in tandem with construction workers, but lays down 3 multiplication as many bricks as human. Can lay bricks in unconventional patterns to achieve novel structures. Craftsman Laboratories and FAO Construction Technologies are manufacturers of bricklaying robots for construction projects. However, this bricklaying works is done by manually in our India, and we can utilize this also by these Craftsman Laboratories and FAO Construction. Another one popular activity which is drilling and excavation. We all aware about this that in construction industry, this work excavation works will take lot of time, lot of labor work involved in this. And nowadays, due to the technological automations, we are able to complete this excavation works with minimum time, minimum efforts, and with the accuracy also. The robot provides accurate, efficient drilling in concrete ceilings and promises for less strain on the workers. In excavation, digging, material handling with increased precision and productivity. That companies like Built Robotics, Automation Solution Incorporated offer systems with sensors. These are basically consist of these sensors, GPS, 3D sites models, AI to navigate, excavate, and avoid obstacles. Even this additional feature is to avoid the obstacle. That sensor sends the data of these obstacles and transmit this data to the operator. Other is JCB skid steel loader, which the model is very much popular in the industry, which is JCB Robot 165, 135 available in the market. Another was in mass tiling, where there is a tiling work is involved. That is so many time is required for this tiling work. This robotic production of tiling work allows for the existence of tiles with unprecedented details. Otherwise, these tiles would be economically unfeasible. Companies like Fluid Dynamics, Neptune Systems, Tespa India are providing the systems for the tiling applications. Inspection of non-destructive tests like technical diagnosis of the bridges, tunnels, and other structures. they uses the sensors like ultrasound, sound, X-ray, and cameras to inspect materials and structures for defects without causing damage. Uh, we are seeing these non-destructive testing are very much helpful for us in the inspection without causing damage to the materials. And these ultrasonic, X-ray, and cameras inspect the materials directly and give the accurate picture of the materials or pipes, etc. These exosuits, what we have discussed earlier, these help in construction worker handling heavier loads without hurting their bodies. These soft fabric-based suits are used to increase strength, improve mobility, reduce fatigue, and prevent injuries to fields like rehabilitations, industry, and military applications. Unlike rigid exosuits use motors to provide targeted assistance that moves with the wearer, offering greater flexibility and comfort. These exosuits are now became popular in the industries due to their helpfulness in to the workers. Automated factories for prefab and modular construction. Prefabricated robots manufactures prefab parts of the building. In this case, the panels are designed within special constraint of the robot. Factories equipped with automated machinery are producing prefabricated components that are assembled on site. This method reduces waste and speeds up the construction. Companies like Catera are leveraging automation to produce entire modules such as hotel rooms with design, engineering, component supply, and off-site manufacturing, all integrated to deliver ready for on-site installations. Just 3D printing in construction. This technology is also very much became popular now because these are giving us the uh, uh, reducing the time and giving the high accuracy while performing. Uh, I will just go through how it works regarding all the areas. It is a digital design. In digital design, architects and engineers create 3D models of the structures, which are then translated into digital instruction for the printer. Second one is material preparation. Specialized fast hardening concrete mixtures and other printable materials are prepared. On-site printing, a large-scale 3D printers, often a robotic arm gantry system, is set up on the construction sites. Layer by layer construction. The printer extrudes the materials through a nozzle, depositing it layer upon a layer to build the structure. And finally, the one important feature is component assembly. Once the structural shell is printed, traditional trades are still often needed for elements like roofs, electrical, plumbing. Robotics are also used in recycling purpose also. This help in sorting construction material and waste for easier recycling. Another very popular use is automated guided vehicles, which is called AGV in the industries. These are segregated in these types like trucks, excavator, bulldozer, and cranes, depending upon their applications. First, that trucks are being developed to increase safety in construction areas. Second is excavators equipped with computer vision and GPS technology. They can navigate job sites, dig trenches, remove debris, and load materials with minimal human intervention. Another is bulldozers, taking over grading, leveling tasks by using laser and GPS systems to create flat, even surfaces with remarkable accuracy. Another is cranes, with sophisticated sensors and computer algorithms, can perform heavy lifting operations and move loads with precision and safety. These are very different variety as per their applications like trucks, excavators, bulldozers, and cranes. And other applications in the construction industry, mainly concrete transportation, their distribution, positioning of steel, fire resisting, painting, In painting nowadays, a lot of robotics are used, excavation and earth moving, what we have seen. Then tunneling works, we are using this. What are the driving forces is India? In this, we will just discuss what the contractor is facing mainly, and what are their driving forces to work robotics in the industries. First initiatives is like Make in India, where and Digital India. These accelerates the adoption of automation and robotics in various sectors, including construction. Second, demand for smart infrastructures. Missions like Smart City Mission, Housing for All are creating a growing need for advanced machinery and faster construction methods to build smart real estate and infrastructure. Industry supports, like so many vendors, manufacturers are available in the industry, they provide the solutions as per your application. Companies like ABB, Hitachi Global, Tata Hitachi, Kuka, Fanuc, Escava, these are pushing for automation, particularly in manufacturing and assembly process, which benefit the construction sector. Mainly, what are the applications is there? They are being discussed by the end users, and what are the changes needed in the robotic system. These are discussed in their R&D department of these companies, and they produce what are the required product should be. Benefits of automation in construction. We are discussing robotics about their benefits. So many benefits are there. We'll just see one by one. Mainly, increased productivity. Automation speed ups repetitive tasks, leading to higher productivity. Enhanced safety. Robots, drones can perform dangerous tasks, reducing the risk of accidents and injuries for human workers. Improved precision and quality. Automated machinery processes ensure higher accuracy and uniform quality in construction. Another is cost reduction. Automation can lower labor cost and minimize material waste, contributing to overall cost effectiveness. Sustainability. IoT and smart building technologies help in optimizing energy consumption and promoting more sustainable building practices. Last, I want to just share with you what are the challenges in adaptation. We are discussing various robotics configurations, their uses, various manufacturers, then their benefits. But how we cannot implement it in our real life construction projects? What are the challenges we are facing for this adoption? We'll just have a look on this. Despite many benefits, adopting automation in construction faces some challenges. Apart from the cost, the need for skilled personnel to operate and maintain advanced machinery is significant barrier. Mainly, we are not getting the skilled personnel to operate these type of robots, and extensive training is involved to train that skilled personnel as per the applications. Many construction company developing countries hesitate to adopt new technologies due to budget constraint. As you know, in construction, this is the most important parameter, that budget. We have to perform the projects within a budget only, and we have to uh, minimize our time by using robotics. We have to uh, judge what are the expenditures are there and what are the benefits from these robotics. Then second is lack of awareness of the benefits. So many times contractor not aware about the applications of these robotics and automations available in the market, and he do the traditional methods and consume a lot of time in completion of the projects. And if the project is delayed, then ultimately not contractor but also the owner, then dependent of the owner, vendors, these are all hurted by this delay in the projects. My just intention to you just share the practical experience what the contractor is facing in real life. with the automations, with the clients, and at site conditions. I think I have covered the basics of robotics, starting from the basics of robotics, their configurations, their uses, then applications, various application driving forces in India, and that what the challenges we are facing in the industries. Hello, I think I have covered my slides.
Okay, sir.
Yeah.
So the platform is open for question and answer session. So before we continue, I'd like to open the floor for participants to ask your questions. If you are having any doubts, you may ask. Please feel free to add them here.
Yeah.
Yes, participants.
I think you have completed more than 3 to 4 sessions.
Yes.
Yeah, so they are much more aware about these robotic sessions. But here I have tried my best to cover up the construction industries, so that you may also aware about the what are the hurdles coming in the projects, and how that are getting resolved by a contractor.
Yes. Yes.
Yes.
So I think we can conclude here. So on behalf of our institute and that S&D College of Engineering, I extend my heartfelt gratitude to our esteemed speaker, Mr. Kalpesh Patil sir, who is Senior Manager at Mechanical at Gavin Engineers and Contractors Private Limited, Mumbai, for delivering such knowledgeable and insightful session today. Sir, your session gave us a deeper understanding of programming concepts, handheld equipments, programming languages, robot anatomy, programming languages like AIML, the key technologies in the constructions, 3D printings, the
Yes.
applications. So they connected these advanced topics with the practical industrial applications that truly enriched our learning experience. So your vast professional background, it is leading large in the EPC projects and handling prestigious clients, added the tremendous value to our session. The
Yes.
example you shared from your own journey made the technical concepts more relatable and inspiring for all participants.
Yes. Yes.
So we sincerely appreciate the time, the effort you dedicated to guide us today. So the
Yes.
clarity with which you delivered the content and the practical insights you provided will definitely help our participants for their
Yeah.
knowledge building, applying in the academic and professional pursuits. So thank you once again
Yes,
for
sir.
sharing your expertise and making this session highly
Yes.
valuable and memorable. So
Yeah.
thank
Yeah.
you so much
Yeah.
from
Thank you.
the team. Thank you, sir. Good night.
Thank you. Thank you, sir.
Yes,
Thank
sir.
you.
So participants are requested to fill the feedback form. I will share the link in the chat box. So it is mandatory to all the participants to fill the feedback form.
I think I have to leave now.
Yes, sir. Thank you so much, sir. Yeah. So with this, I will conclude that today's session is over. We will meet tomorrow
Sir,
at the
feedback form
evening.
is not available, sir.
Yeah, I'm sharing here. Just
Okay.
wait a minute.